class. I just wanted to work through an example of topic 4, or I guess we call it week 4 DQ2 that I gave you, where we're trying to solve an inequality of a certain sort. And so far, I'm not seeing everyone doing the sort of correct sequence of steps. Now in class, I've outlined like 3 different methods of doing this, and maybe I'll discuss 2 of those methods here. Or I may actually make 2 different videos, one with each method. But anyway, I just picked a problem here. Okay, just like you do, I give you a problem, but basically that's what I've done. So I get the problem, x plus 1 over 2x plus 4. That's the problem I get here. And you can come to this sheet that I gave you, and you can set these parameters, right? So you can actually see the plot that you have. These black lines, that's your graph, right? And the question is, when do these black lines fall between y equals 1, that's across here, and y equals minus 1, right? That's across here. And so you're looking to find the, highlighted portion of the axis here. So, this part's pretty easy. It's like minus infinity to minus 3, right? And this part's a little harder. You can kind of zoom in and try to see what it is, right? It's a little hard. We're gonna have to actually do the work to see what it is, but it's like minus, 1.7 something, right? We can't quite see there, right? But we got an idea, right? So when we do the math, we'll actually figure out what that endpoint is there, and then we should have this interval, right? But in any case, we know that what we're going to get in the end is the union of 2, like half open or half infinite intervals, right? An interval starting here all the way out to infinity, and an interval starting here going all the way to minus infinity. So before we even start doing any work, we kind of know what our answer is going to be. That was the point of giving you this to look at, okay? So let's actually attack the problem. So we want to know, and by the way, I'm going to apologize for my handwriting. It's really bad. So we have x plus 1 over 2x plus 4. Okay, so we're trying to, whoops, let's get a pen here. We're trying to solve x plus 1 over 2x plus 4, right, is less than 1, okay? So the method I'm going to use here is what I called method 1 and the stuff that I gave you. Here, I think I'll make this a little bit bigger. Get some more room here. And so, writing absolute value of A is less than B, assuming B is greater than 0, right, is equivalent to saying that minus B is less than A is less than B. Okay, so that's what we're looking for. Okay, so this is what I'm going to use in this one. All right, so what I want here is to look at when x plus 1 over, whoops, let's not do that. Okay, whiteboard trying to be too smart. Over 2x plus 4, whoops, is less than 1 and greater than minus 1. Right, so that's what we're looking at here. Let me clean that up a little bit. Okay, and a good number of people are getting to this step and then just multiplying by 2x plus 4 on both sides and doing some stuff, right? But 2x plus 4 is, it's a variable quantity. So sometimes it's negative, sometimes it's positive. So when it's positive, I can multiply on both sides and these inequalities stay as they are. But when it's negative, I multiply on both sides, then, well, these inequalities flip around, right? So there's actually a few cases we have to consider here, right? And so case 1, ooh, really bad writing. Sorry, you guys can laugh at me. Case 1 is going to be 2x plus 4 greater than 0. Okay, this is the one that basically everyone's assuming when doing this problem. Okay, so this is the same as what? 2x greater than 4, right? And that's the same as x greater than 2. Okay, so this will be part of our condition here. So in this case, all right, no matter what, we're working in the interval to infinity. That's the interval we're working in here, right? Now we can go on. So this is greater than 0, so I can multiply through by 2x plus 4, and these stay the same direction. So I end up with minus 2x plus 4. Sorry, the thing I'm writing on is also kind of weird, so that doesn't help. Let me see if I can. My handwriting is bad enough as it is, but the thing I'm writing on also doesn't help. Okay, and so less than x plus 1. All right, less than, what do we have? 2x plus 4 on this side, right? Okay, now here you don't have one thing, you have two things, right? You have this part, okay, and you have this part, okay, and you can't forget that we have this, right? We actually have three sort of constraints here, right? And we want the numbers we're interested in are going to satisfy all three of these constraints. So in the end, we're going to have an intersection of three sets, right? So let's concentrate on this part here. So here I have minus 2x minus 4 less than x plus 1. Okay, and so this is going to turn into, what I'm going to do, I'm going to add 2x to both sides and subtract 1. So I get minus 5 is less than 3x. All right, and so x is going to be greater than minus 5 over 3. Okay, so there's a condition. That's part of what we have. Okay, so maybe I'll just put that up here in a box, right? We have x less than minus 5 over 3. That's another thing we have. We can read that. Okay, and then we have this other side, right? So the other side here is x plus 1 less than 2x plus 4. And so here I'll pull the x over there and move that over. So I get minus 3 is less than x, right? So that's what I get there. So here I get what? I get this interval, minus 3 infinity. Like that, right? Sorry, I meant to write this interval up here, not that. So this would be minus 5 over 3 to infinity is what this thing is supposed to be. Let's just get rid of that. Okay, so I got, let's see, the interval minus 5 over 3 to infinity, right? And then I've got the interval minus 3 to infinity. So I've got all these intervals here, right? And what I need to do is take the intersection between all of these things. Okay, so I need to take something that's in all of these. Now, what I did in the notes is I just said, let's kind of draw this thing. And I don't really care that I get these exactly right, but let's say minus 3 is here, right? And then minus 5 over 3, so that's definitely something bigger than minus 3. Bigger in the sense of the ordering on the real line. And then so sorry, let me clarify. I mean, it's smaller in the absolute value sense, right? But it means it's closer to 0, so bigger in the ordering of the real numbers, right? And then 2, okay, I don't really, 2 may be further away, but I don't care, right? And so this thing here is like a ray, right? So 2 to infinity is like that ray going out that way, right? And then we don't have 2, so we kind of have like a rounded thing here. Sorry for the. So if you turn in sloppy work, that's all right, as long as it's all there, right? You can see I'm not that neat myself. And then minus 5 thirds to infinity, right? So now these lines will kind of overlap there, right? And then minus 3 to infinity, those things go there, right? But I want the elements that are in all three of these, right? So that's only this part here, right? So this is only interval 2 to infinity is what I have there, right? For that part of the problem, okay? So on case 1, right? If I did make a mistake, I get 2 to infinity. If I did make a mistake, I get to decide whether I want to start over or leave it in. It might be fun to leave it in because that's what you actually do when you do math. Sometimes you make mistakes. But let's go over to case 2. So I'll just come down like this. Okay, so let's say case 2. Case 2. And there's really only 2 cases here. And here we have 2x plus 4 is less than 0. And my problem is, I've already forgotten, x plus 1 over 2x plus 4. Right, so I'm going to have here, right, so I'm going to be multiplying by a negative, right? So I have x plus 1 over, and I'll just rewrite the problem, 2x plus 4. Dang it, I don't know why I keep doing that. Less than 1, greater than minus 1. Right, but now when I multiply by 2x plus 4, everything has to be reversed, right? So I have minus 2x plus 1, oh, sorry, plus 4, right, is less than x plus 1. Sorry, that's exactly what's not true, right? Greater than x plus 1 is greater than 2x plus 4, right? That's what's true now, right? So things have gotten flipped around. And again, we have these 2 parts to consider. We have that part, and we have this part over here, right? So we have those 2 separate kind of things to consider. So let's consider them. So here I have minus 2x minus 4 is greater than x plus 1. So this, this is a lot of repeat, but you have to repeat it. So here, again, I'll bring this over here. So let's keep it like that. And I'll have 3x on this side, minus 5. All right, and so I get minus 5 over 3 is greater than x. All right, so I get that. Okay, so that just flipped around from what we had before. By the way, this is now what? This is x less than minus 2, right? So that's what I get there. Okay, so I get that. And then we have this other part, which is x plus 1 greater than 2x plus 4. By the way, this is not actually how I would do the problem. I mean, maybe I will do another video with the second method because that's actually what I would do. But this is sort of according to the book. And so here I would keep that. And this would be an x, and I have minus 3. All right, so I end up with that. So now I end up with these three guys. And I want to take the intersection again, right? So I have, what's this? Minus infinity to minus 2. Okay, intersect. All right, and then I have minus infinity to minus 5/3. Intersect, right? Minus infinity to minus 3. Like that, right? And so, same sort of picture I have here, my minus 3. Minus 5/3, oops, 5/3. So I want minus 2, I think I want 2, right? Oh, minus 2. Did I make a mistake above? Maybe I did. Sorry. Let's see, minus 2 is actually inside here, right? Okay, and now we're looking at all rays going this direction, that direction, right? And again, we're leaving out these because they're open intervals. All right, so those points aren't actually there. All right, and so clearly when you intersect, you get this part, minus 3 infinity. Sorry, minus infinity, minus 3. All right, this is our final answer for that part. Okay, so now let me just, we definitely made a mistake somewhere. So on the first part, let's see. So here's this minus 3 to minus infinity part, right? That seems to be coming from this case. All right, let's go back up and look at what we did before, because I mean, this is the benefit of being able to check your work like this, right? Let's see what we did up here, because something looks off up here. So first off, this was wrong. So let me start fixing stuff. I think I'm going to leave this in, because this is what you do. Some of you have probably been saying, why didn't you fix that from the beginning, right? But this is what you do. Sometimes you make mistakes and you go fix them. Okay, so this is going to be what, 2x greater than minus 4. Not mess this up again. Okay, so this is going to be x greater than minus 2. All right, so this is going to be minus 2 to infinity, like that. Okay, that definitely changes things. I see, yeah, so that'll change this. So let's fix this. I think all this stuff is actually correct. And we'll even double check on our little plot over here to see that we're getting this correct. Okay, so erase that. Now when I intersect these, okay, so let me go back and draw this again. Right, so drawing this correctly, I have minus 3, minus 2, minus 5/3, right? Sort of that order, right? And again, we're sort of leaving those points out. And then my rays are looking like that, right? But the only ray that's in all of those is this part here, right? So the final answer to this thing is minus 5/3 to infinity, right? And so that's the part here, okay? And now either one of these cases can happen. This is an or. Either this happens or that happens. So an or is a union. Okay. So my final answer then is minus infinity to minus 3 union minus 5/3 to infinity. So that's what we get. And so now that number I couldn't quite figure out over here is probably minus 5/3. So let's check it out. Let's just make sure. Let's do some additional check. All right, so, and you can add stuff to this. You don't mess up my initial version. So I can add in the line y equals, not y, I can add in the line x equals minus 3, just to double check that we're getting, yep, that's what I want, x equals minus 3. And then let's just, whoops, okay, if you click and hold, it lets you, okay, turn on. Click and hold, and it lets you format this. Okay, so let's put a dotted line. Let's make it thin. Okay, so there, that's one boundary right there, so that's clear. And let's try the other one. The other one was x equals minus 5 over 3, right? And so you see that's that blue line right there. And so let's click and hold that. Let's make it red, make it dotted, put 1 there again, all right? And you can see that that's exactly what we were given to begin with, right? We had a little hard time guessing what that was to begin with, right? But there we go. So there we've sort of checked our answer there, okay? Um, let's see. I guess I can copy. Let's see. Either I'll make this one long video, or I will make it 2 videos by chopping it. Okay. So sorry if I make it one long video, some of you get to hear me mumble about this. I was thinking about doing the other way of doing this. So let me do that. And let me just clear. I was just going to clear all this. Okay. So let's just clear it. Okay, so again, and let me zoom back in. Okay, so again, we're trying to solve, whoops, yeah, it's just x plus 1. Okay, absolute value of x plus 1 over 2x plus 4. Okay, and we want this to be less than 1. Okay, so here the point here that I'm going to work with, and in fact, I guess first I'm just going to do what we did before. So this is going to turn into x plus 1. Come on, over 2x plus 4 is going to be less than 1 and greater than minus 1. So I'm interested in x satisfying those things there. Oh, bus going by, lots of noise. Okay, so this is a function f of x. Here's the idea. This is a function f of x. And if it flips from being below 1 to above 1, it's actually got to go through 1. Now that's actually sort of a deep fact about real numbers, but it makes sense here, right? I mean, here's our picture, right? So, if I go from, say, here's 1, right? So if I go from below 1 to above 1, I've got to go through 1, right? So in fact, let me put the line y equals 1 so we can see these bounds nicely. So y equals 1, that's that green line there, and then we put y equals minus 1. That's our other boundary we're interested in. All right, that's that line there. Let me just make both those green so we can see them, right? So those are the lines we're interested in intersecting, right? Okay, so the point is I can check to see where these things actually equal 1 or equal minus 1, and then I can check to see whether or not my function is, below 1 or above 1, and I can just check all those things, right? The other issue though is your function might skip over, right, from minus 1 to 1. It might skip over there where it's undefined. So where it's undefined, we have this vertical asymptote, so I can throw that in there too. Where are we dividing by 0? So we are, so see, we're dividing by 0 at minus 4 over 2, right? So let me throw that line in there. All right, so that's that asymptote right there. And so let me put that on there. I'll put that green too and put it dotted right. So that's sort of a bad line. So it can jump from one thing to, from one point to another without passing through any values, where there's something called a discontinuity, where there's a big jump like that, right? So basically we're going to find out where this function is equal to 1, where it's equal to minus 1, and then consider where this discontinuity is, and we will just check to see if the function has the right values in those intervals, right? So I think this is actually quite a bit easier, right? Because all I'm doing now is I'm just solving this. I say when is x plus 1 over, stop that, over 2x plus 1 equal to 1? I just asked that question, right? And so now we're just solving this. So now I don't have to worry about plus, 2x plus 1. Why did I change to 2x plus 1? Sorry, 2x plus 4. I don't have to worry about whether 2x plus 4 is positive or negative now, right? I just, now I'm just solving an equation, so equals 2x plus 4. All right, and so what do I get here? I get minus 3 equals x, and I'm done, right? That's okay, so that's where my function equals 1. Okay, so let's check. So then I have x plus 1. I have 2x plus 4 equals minus 1, right? And so I have x plus 1 equals minus 2x minus 4. And so I get what? I get minus 3x equals, do I get minus 3x equals 3, right? So x equals 1 is what I get there. Let's see, am I doing something silly? Minus 3x equals 3, x equals 1. I feel like we didn't have x equals 1 before. Oh, no, yeah, no. Yeah, nope. Okay, so you guys catch me making all sorts of mistakes. I mean, catching mistakes is part of what you need to be doing, right? Maybe it's good for you to see me make mistakes. Okay, so I get 3x equals minus 5 is what I get, right? So x is equal to minus 5 over 3. Okay, so I got that. Minus 5 over 3. Okay. Okay, and the other thing I'm interested in is where is this thing, not this thing, that thing. Where is it discontinuous? So that's going to be at x equals minus 4 over 2. That's where it's got that big jump, right? So x equals minus 4 over 2 is a point I'm going to be interested in, which is, which is just x equals minus 2, right? X equals minus 2 is a point I'm going to be interested in. Okay. So now things are a little different. I'm going to, I just like, now you just sort of draw a number line, okay? And you indicate the points you're interested in. So let's get them in the right order. So I've got minus 3. Now we saw these points come up. We were doing our computation earlier. So minus 3, minus 2. You don't have to even worry about getting these exactly where they belong, right? Minus 5 over 2. Okay. Now actually this point at minus 2, we know a little bit more about that. That's not actually a point in the function. There's actually like a hole right there, right? So we know there's a hole right there. All right, and all we're going to do is we're just going to, take values of the function here, 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 and here inside those intervals and ask, is the function between minus 1 and 1 in those intervals, right? And if it is, we're going to say put a check mark, and if it's not, we'll put an X mark, okay? So, basically you just make a table now. So we have X, our f of X is that function right there, right? So our X, all right, we have over here X plus 1 over 2X plus 4. And you just check, right? So an obvious point to check up here, say, for example, would be 0, right? So if I plug in 0, right, well, then I get what? 1 over 4. 1 over 4. That is between minus 1 and 1, so I just check, right, and we're done, right? What's the point between minus 5 or so? This is minus 2.5 and minus 2. Oh my gosh. So minus 3, right? Minus 3 is over there. Minus 2.5. Oh, do I have these in the wrong order? Sorry about this. Sorry, this is 5 over 3. I can't read my handwriting. That's what's wrong. Okay, minus 5.3. Sorry, minus 5 over 3. 5 over 3 was about like minus 1.7 something, right? So I can choose what? Let's just look at it. Let's cheat, right? So here's minus 1, here's minus 2. I can take something like, what would this be? Like minus 1.8, for example. Okay, so that's kind of a pain, but whatever. Minus 1.8. Okay, that's in between there. And now we have to do some computation, right? So minus 1.8 plus 1 would be minus 0.8, right? And then this would be minus 3.6, 0.6 plus 4, right? So I got a minus 0.8. Okay, so this one's kind of a pain. I mean, you could use a calculator for this. Maybe I should just do that. And then I have what? Minus 0.4 here. No, I have plus 0.4 here, right? And so so this is now double that, right? So this is minus 2, right? Okay, which is bad, right? That's not between minus 1 and 1. Okay, now in between here, I have to choose something like, what, minus 2.5. Okay, so again, I have to kind of do this annoying stuff, right? Minus 2.5. By the way, I'm perfectly fine with you plugging this part into a calculator. I'm just going to keep messing with it here. So minus 2.5 plus 1 would be minus 1.5. All right. Then 2 of those would be minus 5. Okay, plus 4. All right, so this would be minus, this would be minus 1.5 over minus 1, which would be 1.5. Okay, which is bigger than what, it's outside the interval minus 1 to 1, so that's bad, right? And now I can take anything out this way. So I can take like minus 1,000. Okay. I can take whatever I want, right? And so then I basically get minus 1,000 over minus 2,000, right? So that's close to 1 over 2, right? So something close to 1 over 2. So that's good. That's between -1 and 1, right? Check, right? So there's my intervals, right? My intervals are -3. I don't know, can I write green over blue? Right, there's my interval. That I have that interval. Now we're not including -3 because we're doing strictly greater than, right? And then this one going out that way, same thing. We're not including that because we're doing strictly greater than, right? I mean, these things are strict, so we're not including the endpoints, right? So we get our same answer, right? But we do it a very different way here, right? By checking points. I personally I find this much easier. You don't have to worry about whether you're multiplying by positive and negative things and doing all those cases and stuff like that. But you do have to go through and sort of make this little table and check values. So it's got its trade-offs, right? They're actually both important methods to use. So I guess in all honesty, if I could ask you to do both, I'd ask you to do both. But you should do one of these completely correctly. Thank you.